This is how we write hello world in C. And this is how the assembly code of the same program looks like. So let's see. What is this? This is an x86 64 assembly language, which is built by AMD. So why is it important to learn it and where is it used? Let's check. It is used in most of the personal computers and workstations and servers and most new supercomputers. So it's relevant to learn that. And why should we learn that when we have high level programming languages like C? Because x86 assembly language is used to write programs that directly control the hardware. It makes the code more efficient and makes the program run smoothly. So let's learn how to write this and the syntax of this assembly code. So before diving into this, you should understand what are registers. This RBP, RSP, EDI, all these are registers. So we should learn that. So registers are high-speed memory locations that are built directly into the processor or CPU. See, this is how our CPU looks like. We have the ALU, arithmetic and logic unit, the control unit, and here we have our registers. So why registers when we have RAM or our main memory? Because these registers are even faster than the RAM. So using them to store data that is frequently accessed can significantly improve the performance of a program. The CPU fetches instructions from the main memory and stores them in registers for easy access. It also stores operands or instructions in registers. The CPU also stores calculations for temporary storage in registers. So let's go back to the assembly code. So let's learn how we can read this. This section, the first line, is a read-only data section that contains string constants. This line tells the compiler to define a string literal with the value hello world. Okay. Then we have the main. This corresponds to the main function of our high-level C code. As you all know, the main function is the entry point for all C programs. So after we enter inside, then we have the push RBP. What does this mean? This line pushes the value of the RBP register into the stack. So two questions arises. Why stack and what is RBP? So let's check what is RBP first. The RBP register, also known as the base pointer or frame pointer, is a general purpose register in x86 64 assembly language. The RBP register is typically used to store the base address of the stack frame at the beginning of a function. For example, in an array of 10 integers, let's take a stack of 10. We have 10 integers. Let's imagine we have 10 integers. 10. The base address is the address of the first element in the array. So base address will point to the first element. The address of the fifth element of the array is calculated by adding 4 to the base address. So to find the fifth element, we will add plus 4 to the first. Then we will get the fifth. That's what base address means. So the base address of a stack frame is typically stored in the RBP register, which is this register. Why stack when we have a lot of other data structures? The stack is a last in first out or LIFO data structure. That means that the last element pushed onto a stack is the first element popped off. Like if we push the main at the last, Then the first element to be popped is this main. That is meant by last in, first out. So when a function is called, its arguments are pushed onto the stack. The function's local variables are also pushed onto the stack. When the function returns its local variables and the arguments are popped off the stack, this ensures that the stack is always in a consistent state and that each function has its own private workspace. The stack is also used to implement recursion. It is also a main reason. Recursion means calling itself. Like this function main, we can write it here and again call this function. And this is meant by recursion, calling the function again and again. Okay, so let's move on to the next slide. Move RBP RSP. This line moves the value of RSP register into the RBP register. So what is this RSP register? RSP register is the stack pointer. It always points to the top of the stack. Just to remember, the last thing that is pushed onto the stack will be on the top. So this RSP register points to the top of the stack. The relation between RBP and RSP registers. So the RBP register points to the base address of the stack frame, which is the first byte in the region of the memory that is used to store local variables, function parameters, and other data. Before moving any further, we can discuss about stack frames. You should have heard it when I said. So, what are stack frames? Stack frame is a region of memory used to store local variables, function parameters, and other data needed for the current function, which is our main functions. In this case, it is created when a function is called. Stack frame is created when we create this function and destroyed when the function returns. After this function is returned, the stack frame gets destroyed. In other words, we can simply say it is a memory management technique used in some programming language for generating and eliminating temporary variables. Don't need to stress on that word, just a memory location that we use to store the local variables. Just think of it like that. Okay. Now let's move to the next line of the assembly. As this instruction move RBP RSP copies the value of the stack pointer to the base pointer register, this effectively sets the base point address to the top of the stack, which is base address to the top of the stack. Then the next line, move EDI offset flag instruction copies the address of the string constant .lc0 to the EDI register. Copies just the address, not the value. Then the next line, move EAX0. The move EAX0 instruction sets the EAX register to 0. EAX register is used to store number of arguments passed on to the printf function. In the next line, the call printf instruction calls the printf function to print the string literal hello world to the console. Let's see how this happens. When the call printf instruction is executed, the address of the next instruction, that is, the address of this move EAX0 is pushed down to the stack. Then the program jumps to the printf function. The printf function uses the address in the EDI register, which is this. What did we store in the EDI? The address of this string literal. So the printf prints the string to the console and the printf function returns. So it is popped. Now the value inside the stack is the address of the next instruction, which is this move EAX0. This line moves the value 0 into the EAX register. This is the return value of the main function. Then the pop RBD. This line pops the value of the RBD register from the stack. And finally, the ret instruction returns from the main function. So that's it for today.